Hello, hi there, Teufel. Hello, Blurry Cat. Okay. So, interesting things that happened now, well, recently, before we start. Let's see. One is this: there's a bug in SQLite that was fixed recently that could cause data loss. We should probably update the version of SQLite that we use, which also reminds me that I think we grab SQLite from from the bindings package, and it shouldn't be that way. It should be that uh, it should be that we build SQLite on our own. Actually, the bindings library providing SQLite initially was a convenience, but now it's detrimental because we don't want that. I mean, if I remember correctly, there are ways of turning that off. So, like, the library does the right thing. Um, but conceptually, uh, now more than ever, I think I would like on all your code base SQLite package that only contains SQLite, that does the packaging just right, with everything being just right. And then from there, we make a bindings library if we want to. Actually, considering that my bindings library is an abstraction over an existing bindings library, I should make my own SQLite bindings library at this point, honestly. Let's see. I'm really happy about the new things Andrew did. You mean, wait, what are you talking about? The two PRs to get us unblocked on Windows with Awebo? Yeah. Yeah. If you mean that, yeah, for sure. Question about C library bindings in Zig. Is it expected that such wrappers allocate despite not taking allocators as arguments? That is a good question. Is it expected? Well, the status quo, if you do not do a lot of um, um, a lot of sorry, so by default that's the behavior that you get, right? So like you add a C library and you just start using it. By default it will secretly use malloc, and that's it. Then you have libraries that allow you to override malloc. um, And I guess depending on which ways they allow you to override malloc, that could be maybe more or less useful compared to what you're doing. Because, well, you know what? I would argue, I guess normal overriding of malloc is not particularly useful because it's still going to be a global. So that doesn't help. But there are some libraries that allow you to specify allocators with higher granularity. So, for example, I believe that um, I think 3-seater allows you to bring your own allocator on a per parser basis. I might be wrong about it. I might be wrong about it, but I think that is one example where you can have a higher level of granularity. And if I'm wrong about 3-seater, there is at least one C library out there because I've seen it. So it can happen. It's just not going to happen every time, right? So um, if you have a C library that does not allow you to have a per instance of thing allocator, then I guess you could accept an allocator and kind of like LARP being allocator friendly, but that's a bad idea. I wouldn't do it. Like what I was saying is like you literally accept an allocator and then discard it because you do nothing with it. That seems dumb. Um, Technically, if you're super evil, you could override malloc, the global malloc, with a thread local, and then every time you want to allocate, uh, you swap in the allocator that you swap in your allocator implementation while the interface that connects to your allocator implementation temporarily for your thread local, calling to the C function, and then swap it back. But then again, this only works if it allocates at the beginning of the lifetime and not in the middle of it. If it allocates on its own in the middle, then the swappy thing, which is already kind of insane, that doesn't work at all at that point. So I would say that if a C library just assumes a global allocator, there's nothing you can do. You have to feed it a global allocator, and that's it, unfortunately. If a C library accepts an allocator, then yeah, you have the opportunity to do the work to wire that to Zig. There is only one problem. C libraries assume that the allocator will remember the allocation length of every allocation, while Zig libraries do not. Zig libraries, in Zig, when you free a slice, you are expected to provide not just the base pointer of the slice, but also the length. And you are expected to provide the correct length of that slice. C allocators do not expect you to do this because they will store internally the length of a pointer. Because I guess in C, the general expectation is that you pass around pointers, but not their length, and you kind of like reinterpret the length of an array depending on what you're trying to do. Like, for example, you could treat like the last few bytes of it as some kind of optional suffix, and then you don't care to keep track whether you're using those things or not, and whatever the heck, and then you just pass the pointer to free, and then that's it, you're good. So that is another point of friction. So that means that if you want to be able to use your own allocator, I think you will need an adapter that essentially remembers lengths for you. Well, for you, for the C code. That's probably a big reason why C wrapper libraries don't often, if ever, override the C allocator. I don't know. So in any case, this happened. Then another thing that happened is that MLAG merged a ginormous PR that redesigned type resolution. And the good news is that the fallout of those changes is extremely minimal. Like breakages are extremely minimal. Truly extremely minimal. So this is all well and good. We're going to continue with noise space allocators then. Yeah, well, what library are you talking about specifically? Oh, libgit, I see. Yeah, I think that this will be more interesting in the future as libzig, what is it called? Zig libc. I think it's Zig libc. So as Zig libc gains more steam, I think at some point maybe there will be something interesting that you can do. Well, once essentially your clib is entirely implemented in Zig, maybe that will give you something nice to do at that point. I wouldn't worry in the meantime. I think that we are currently in a transition period when it comes to this stuff, and so yeah, it's fine for now. Okay, so what am I doing today instead? Well, so yesterday, was it yesterday or the day before? I don't remember. Did I stream yesterday? Yeah, I did. Yes, it was yesterday. So yesterday we got screen share working, kind of, right? The super basic, super janky. So first of all, only one stream at a time, because I had only one buffer where I was collecting data to make up the same packet in full again. And then the second problem was that we were like extremely naively swapping in frames as they would come in, and that was like causing all kinds of jarring, video stutter effects. And that is because those things should happen on a timer. I mean, DVUI has a timer, so we were trying to get the timer to do the stuff for us. But obviously that timer, like if we always try to print on screen the latest frame as soon as it arrives, the timing with which that frame arrives will be affected by jitter. Even in a local system, we learned this with audio. We already learned this with audio, that even in a local system like local loopback, local server, local everything, at least on macOS, there's like 5 milliseconds of jitter, easy. 5 to 10 milliseconds of jitter, you can get those very easily. So 5 to 10 milliseconds of jitter means that if you're doing a 30 frames per second stream, where 30 frames per second stream means that what is it, 33 milliseconds per frame, I think. Is it 33 milliseconds per frame? Yeah, I think so. So it means that you have 33 milliseconds between one frame and the next. And if you fuck it up by 10 milliseconds, you're fucking it up by 1/3 of what you were supposed to do. So like it's noticeable. It's noticeable that that you're fucking up getting frames on the screen. So what does that mean? Well, that means the obvious, essentially, that just like we had to have a jitter buffer for the audio, we're gonna need a jitter buffer for the video. And I'm not gonna do this now. I actually agonized over this choice yesterday all evening and then today in the morning, because I was thinking, well, this video will need to have its own audio, so maybe we should already immediately attempt a jitter buffer that does both video and audio at the same time. So that we don't overfit, so that we don't make something that is overfit for video and then we fail to adapt it for audio, and then that requires essentially to do all the work again. But I try to think of an elegant manner to deal with video and audio all at the same time, and I have too many questions in my mind. Like, I don't understand the problem space intuitively well enough yet to feel like I'm gonna do a good job uh, attempting everything all at once. So we're going the long route, and we're doing the video jitter buffer first. And I don't know, we try to do it well, and then I guess the idea is that I'm gonna make something that works decently well enough. And then instead of polishing it to perfection, we stop there and then we try to add audio and see what that entails, and then only then we try to get this whole thing to the finish line. I don't know. We'll see how that goes. So this is the current state of things, essentially. So we have a frame. Also, I started refactoring some of the code. Like I created what I was previously calling a video caller. I'm now calling a video stream. So we have a caller instead of being made up of multiple callers. Now caller is made up of a voice stream, which I have to rename it. Yeah, but it's gonna be a voice stream, a video stream for the screen share, and a video stream for the webcam. So yeah, that's kind of where we're at. So essentially, we need to make a jitter buffer for video. It shouldn't be too bad because we already made one. We just need, actually, I think I might as well. I think what I will do is that I will, instead of having a separate jitter buffer, like as a separate file, I think I will take the previous jitter buffer. I'll paste it inside the audio capture, because that actually inside audio stream, the upcoming audio stream, I'm going to paste it in there because that's where we're going to use the audio jitter buffer. And then I'm going to paste it here in video stream and change it to adapt it to the needs of the video. It should not be too bad. I might be too optimistic, but I think that by the end of today's stream, we might have a jitter buffer for video going, hopefully. Last question that I don't have an answer for yet is, how the heck do we schedule correctly which frame to play? That I don't have an answer for. So I don't know. We'll see. In any case, give me a sec. I'll be right back, and then we're gonna start. Yeah, okay, I'm back. Okay, let's get this party started. So we're saying that we want to take jitter buffer, copy it, and make it a also playback packet read. Oh my god! Don't tell me that play. No, it's still in here. I think. Yeah. So this is gonna go in audio stream. Uh, important thing to keep in mind. Okay, so everything goes in here. And now we want this also in video stream. And then we're going to want to adapt it. So hmm. Okay, so this is all fine. Why do you need IO? I don't think we need IO. Awebo we already have. So there's logging. Video stream. These are the settings of how much we're going to buffer, which is not a bad place to put them at the top of video stream. Yeah. So this can just be a jitter buffer. Okay. Oh, there we go. Because this guy is IO. We wanna call IO. I mean, this collects stats. Probably not a bad idea. Okay. So I'm wondering if I should just refactor audio right away. Um, maybe I should. No, let's do video first. Okay, jitter buffer. Actually, what are gonna be our main things? So more than swap frame. So swap frame. So okay, so here's what we know. What we know is that we cannot afford to keep a frame around anymore. We know that we're going to need to have this thing make a frame for us, but we just cannot keep it around. So there is no point in us to be aware of frames. There's not going to be a frame that we swap anymore with an atomic value. There's just going to be a jitter buffer, and the jitter buffer will have to contain pixels. It cannot contain a frame is like a OS resource that we can only hold on to for a brief period of time. So long story short, you can't stuff those into a jitter buffer. Jitter buffer is for stuff that you plan to hold on to for a while. So that means that a few things will have to change. So create, destroy, decode new frame. Yes. And then this is not a swap frame. This is going to be um, frame push frame. Frame push. And I think this should be frame decode. Frame decode and then frame push. And frame push, I think this shouldn't even be frame push. This should be pixels push. The problem is who owns the pixels? Because we're going to need to copy them out of the frame. I think, I mean, maybe, but at the same time, we know how big this thing is. These pixels are going to be whatever is the pixel size times a matrix. So we know the length of these guys, although they will be dependent per stream. So we need a more of an object pool than anything else, I think. Okay, so we don't even okay, let's change this to decode packet. And then push image. And this is going to be something like c.packets dot write packet. Okay, almost, not quite. Not quite. When custom game engine in Zig from zero, um, there's a project doing this. I mean, there's actually more than one project. There's first of all, there's like Zig Game Dev, which is not exactly an engine, but it's like a collection of standard tooling that game dev people use, standard libraries that game dev people use, and so you get Zig game dev, and you have you should have like a viable ecosystem of libraries that you can use to write stuff in Zig native. Then, if instead you want to see a proper like I don't know what to call it, like all-encompassing framework, like a less of a connection, less of a toolbox, more of a cohesive design. There's Mac Engine. So Mac Engine, the people working on it were also, I think, at some point making their own shading language to replace WebGPU. Or well, whatever it is the shading language that people use with WebGPU. I don't know if the shading language has the shader language has a different name. In any case, um, yeah. So some people are doing this. Okay. Sadly, Mac isn't that now. Yes, it is. Um, So I'm realizing that here we have a problem because I think one jitter buffer isn't enough. We want a jitter buffer of images, but then we need a buffer for collecting pieces of packets. So the pipeline is more complicated than the one for audio because in the one for audio, every time we get a UDP packet, that's it. That's a full audio packet, and we're happy now. But with this guy, first we get a bunch of UDP packets that we need to collect, and then collapse um, into one uh, video packet essentially. Um, so we kind of need a two-tier jitter buffer. We need a jitter buffer for chunks, essentially a chunk buffer, and then we need a chunk buffer, and then whenever a frame is done in the chunk buffer, that needs to be given to the jitter buffer, and it needs to be sent to the coding, and then when the coding is done, that pushes a new image in the jitter buffer. But also, here's the thing: the the coding step has to happen in order, and it is slow, so it cannot happen at the last minute. What I'm saying by this is, hmm. So with audio, so far it seems that we can do the thing where um, audio thread runs, audio callback runs, we run out of samples, so we grab a new packet from the jitter buffer, and then we decode it immediately, last minute, and we place it where it needs to be, and life goes on. But with videos, I don't know if we can do this, because with videos, the coding, as I've set it up now, is asynchronous. We could turn off asynchronicity. Um, asynchrony. We could turn off asynchrony and make it a blocking operation. Uh, but that now has two problems. One is that we're blocking whatever thing it is that we're blocking, and the second is, how long is it going to take to decode that video frame? Uh, the problem is that I don't have an intuition for how long it takes to decode a video frame. Hmm. Hmm. So yeah, we need a chunk buffer. Chunks. And actually, maybe this is packets, and then we have frames. something like this. Maybe frames could be a normal ring buffer. Hmm. Okay. Um, let's start with the jitter buffer that collects chunks and makes packets. That we need for sure. So that means that we want a. So we don't want a decode packet here. We want a function. I mean, we could make a function that accepts a chunk in theory, or we could just have the network thread call into that. But this might be more logic, so let's do it here. So um, push chunk. Um, okay, push chunk. Okay, what is a chunk? A chunk is um, a chunk is a UDP header plus some data. Um, so I think this should be push chunk with a given sequence number. A chunk with a given sequence number. And then body. And here we do const header, video header. It's going to be of type Awebo protocol media. video. So you grab the video header. And then from the video header, we know what the sequence number is. From the video header, we know what the sequence number is. So now we need to stuff it in the jitter buffer. The problem is we need to stuff it at essentially at a open existing index. So that means that we need essentially a slice of what's available in the jitter buffer, and then we need to decide where to put it and do allocations if necessary. I think we want to delegate all of this logic to the jitter buffer. Like in here, I think for us there is very little to do. Except maybe the jitter buffer could tell us to decode something. Do we decode as a response to us receiving a packet? No. We decode based on the playback state. Although we should decide when we are like playing or not, which is currently decided by the jitter buffer. Right now, the jitter buffer decides whether we are playing, buffering, or whatnot. Okay. Yeah, so maybe we don't even do this. Maybe we just do this. Just delegate to the jitter buffer. Okay. Okay. Oh, this guy had a decoder in it. Interesting. In our design, this is the guy that had a decoder in it. Yeah, that might be fine for audio, but for video, it's not this guy that can do that anymore. Okay, let's remove the dread stuff because we're not going to do that anyway. There's no restarts. There's just sequence number. This statistic counting also we're not going to do. playback packet ring. Playback packet ring. What's in this guy? Yeah, this is the actual memory. Okay, let's start from there. Is there a better name for it? Playback packet ring. I don't know, packet ring. Okay, let's look at the packet ring. Indexing direction for faster sorting. Yes, by the video thread. That I like. Although I don't think if it matters much for us, does it? Does it really matter for us at all? Because aren't our things just pointers? Isn't our ring just a ring of pointers? Let's think about it. Hmm. I mean, for us, a packet is a sequence number and a pointer and an array list. A sequence number and an array list. What else is it? Hmm. Uh. Yeah, I think we might be fine without the interaction and not SOA. But the day that we had audio, who the fuck knows? Hmm. Well, for now, okay. For now, let's do this. Meta, data, node red. Data is essentially for us what's gonna be data. Data is going to be the array list. Actually, not even an array list. Uh, yeah, I think we should probably try to make it an array list, shouldn't we? No, we shouldn't. Hmm. It should be buffering length. Except the buffer is a slice. Yeah. It's a heap allocated slice. Yeah. Okay. Now here's the problem. The problem is um the problem is that there is going to be a right end. We will collect stuff on the right end, and we're not committing that right until it goes to the reader side. Like, how is this going to work? This jitter buffer has to behave very differently than the other one that I wrote. Holy shit. While we write, we're gonna have a number of open packets that we keep filling chunks into. Then when one of those is complete, we need to send it to the reader side, essentially. We have to send it to the reader side. And then the reader side will try to reorder stuff last minute. At least that's how we were doing it before, which I do think makes sense. Now the problem is that now write is not just something that this is complicated now, way more complicated, and it requires to have state. This guy cannot be this. This guy needs to be splat 0. This guy needs splat 0. Data can be garbage, but sequence has to be splat 0. I'm starting to wonder if this should be a deque instead. But if it is a deque, it cannot be atomic. Okay, so let's see. How does it work? Okay, so we try to write. It might be full. Then otherwise, we do, what do we want to do? What we want to do is we want to find in the space of of free slots if there is a slot that has either our ID or 0. So read is always behind writer. So I guess we can do this for uh, r.w. Although I think this is for uh yeah, rw. Just to double check. If it's 0, 0, then it's full and there's nothing we can do. Or it could be empty also. Well, no, yeah. If they are the same and it's empty. Oh damn. Mm, we need a way of getting the range of packets that are not written and that are not yeah, of empty space. So I guess we depends on whether W is bigger or lower than R, right? Which is what we do also in other operations. Let's see, slices return to slices that contain written data. We kind of want the inverse of this. Maybe we should have empty slices. Then we call len. Is there a date for the 016 release? No, not really. It should be in the next couple of months. So should be relatively soon, but there is no fixed date. So I think we could do something based on len though. If we have these indices in len, it should not be too hard to know what the empty slices are. So free is essentially buffer len minus L. And we know that these guys are in front of W. Starting at W. So that means that free hmm, also we're looking at indexes, but we shouldn't really be looking at indexes, should we? Although we could. Why not? That's fine. Hello, Neurosite. Interesting. We kind of want to do the same as here, except we would like for this to not be read index, but to be just index. So that in here we can do index equals W. Okay. Okay, so this should give us slices to empty slots essentially, which now we can use when writing. And so we can do for slice, and that's going to be an index IDX. Okay. So what's our goal now? Our goal is to find a slot that either has our same sequence number, or we make a new one but I think we still want to sort them every time we do this. We always want to make the oldest thing, put the oldest thing at the back. Yeah. You could move it when it's done, but what is the point? Yeah, no. We keep them sorted. So we do this. Yeah, and we look at meta and we sort them by sequence. There's no restarts. There we go. Okay. So in here, I think we want also an index. Not like this. I think we might not need this. So we want to say if sequence equals so if we find a slot that already has our thing, great. Then we want to chuck it in there. Place chunk here and return. Otherwise, if sequence is 0, none of the previous slots had same sequence, must start a new one. Place chunk here. And we also do, let's make this meta writable, and we say meta.sequence equals sequence. Okay. And then return. And then actually here I'm doing empty slices, so that means that we are not doing this. So we got here, it means that it's an error full. I don't think we're doing this. Are we increasing the right index? No. Well, we're not. Oh. Well, okay. Place chunk here, otherwise it's full. Do we really not push forward the right index at all? So here we assume that we can operate on this like empty memory for as long as we want. The problem is that we're gonna starve the reader if we don't release stuff. You know what? I might have been right in saying that we don't sort these guys whenever we want, but we sort them when they're ready. And whatever is ready, we push to the back and we increase the writer index. And then in case they never complete, what do we do in case they never complete? I think the writer needs to have a the writer needs to understand when it's time to give up. When a packet is too old, no matter what. Yeah. Which would mean yeah. It would mean making this better. Okay. Okay. I'm starting to understand. Dread right? No. Um yeah. So this is this useful? This is not really useful. Maybe it has its own advantages though. I'm gonna keep it. Okay. Okay, I'm gonna go. Tea is ready. I'm gonna fill my cup, and then we'll continue with this code. Okay, so far so good. Okay, for now, let's assume that if sequence is 0, none of the previous slots had the same sequence, and we must start a new one. Let's assert that the chunk has well, I'm not gonna write, not gonna call it data, or yeah, no, we should call it data. We do call it data, and here we do const header, well, video header. Start on line 1 of const proto equals awebo dot protocol dot media. Actually, let's call it media. Media dot video equals pointer cast of data pointer, and then actually, why am I doing the pointer casting? I mean, I could, but why am I not parsing it? Yeah, and this should be called body. Yeah. There we go. Okay, that makes a lot more sense. In these guys should all accept body here. Except this first one, which should be UDP data. UDP data load by body. Okay. Perfect. Then after with the header dot first of chunk. This is a temporary assert. This we cannot assume this, but for now we will for simplicity. And then all we do is we allocate based on. This is the code that right now we have in network. It's this. Mm, 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 mm. It's essentially this. Okay, data per packet. You know what? This should be a property of video. And this now is like this. Okay, so now video has data per packet, which is useful. So now we can go in video stream, and instead of doing this mumbo jumbo here, we can do what happens to these buffers. Do we, I guess we keep them there, we reallocate them. So we need a GPA. And we do pb dot data at id x equals actually dot buff. Actually, then we reallocate this. Okay, let's see. Reallocate. This function requests a new size for the existing allocation, which can be larger or smaller, the same size as the old one. Remap, which returns null when the allocator implementation cannot do the realloc more efficiently than the caller. Resize, which returns false. The allocator implementation cannot change the size without reallocating the allocation. Hmm. Allowing relocation. This is mem copying. That's annoying. This is mem copying. It's calling row remap. Row alloc. Okay, so it seems that what we do is free and does this guy really need to be on array list? Yeah, this guy needs to be an array list. At the end of the day, that's what it needs to be. So let's make it so. So data, it's an array list. And we cannot do this. We need to splat. We need to splat empty. Splat. Splat empty. So that makes this whole thing way less problematic. Okay, so that means that let's assert that length is 0. And now we can copy more code from network. Do we call clear retain capacity? Well, we could do that. Yeah. Okay, it's literally this. Assert first of chunk, clear retain capacity, ensure total capacity is data per packet. So that's going to be media dot video dot data per packet. Actually, this should be data per chunk. Data per chunk. Screen dot chunk. Screen is video header. +1. Okay. That does ensure total capacity. That allows us to append. We do append data. Perfect. And we return. This is still a simplified approach, but yeah, I'm actually kind of changing my mind about this being an array list. I am indeed changing my mind about this being an array list. This is the wrong choice. This is definitely the wrong choice. This is without a doubt the wrong choice. Never mind. Walking it back. GPA, yes. But data is a buffer by default of length 0 and a len usize. Does len matter? Does len matter? No, it's more like this is more like a less chunk len. And then like total chunks. Although does it chunks remaining? Although, oh man, this is where, oh shit, this is where this gets funny. About missing chunks. Now, here's a problem. every time we receive a packet, we can write it at the right offset in the available buffer. So even if they're right out of order, we can always put it in the right place. The problem is if we get a duplicated value, then what the heck do we do? So the strategies available to us are we could zero out the memory and say, well, if the memory is not a perfect zero, then we assume that this thing was already written. But that requires zeroing the memory, testing the whole byte range for equality to zero every time. Um, and that sucks. An alternative is to have a companion allocation, essentially a companion bit array where we flip a bit to one for every time we receive a given packet. So that way we recognize duplicates. So that means that like a missing chunk count, that's not going to be a thing. We do care about the length of the last chunk though when we discover it. So buff scene chunks bit static bit set, dynamic bit set, dynamic bit set unmanaged. Let's go. Init empty, init full, resize. If new line is not zero, the init must eventually be called. The init clone is set count, set value. I think the problem with resize is that it's going to copy the old data, which we really do not care about. Yeah, equals realloc. So we don't care about that. I guess we can init it with length 0. We do init with length 0. Oh, does it not have a like a static initializer? Hmm. Kind of annoying type to use. It also calls resize. What happens when you call resize with new len 0? Old masks, old len, which is going to be 0, new masks. I'm assuming this is going to be 0. So if new mask is 0, then it calls free old allocation. Okay, I think we can init this. I think we can init empty this. If we init empty this and then we call the init, what happens? Calls resize allocator 0. Okay, I think we can do a 0 init on this guy and we should be fine. Okay. So with this, then we can say um, data is going to be this. And then we say data dot scene chunks dot the init. Data scene chunks init len init empty GPA bit length we don't know. It's this. Looks do. Total chunks. Okay. Okay, data.scene chunks dot set index video header.chunk. Mm-hmm. Then we need to do the same for data.buff. I'm gonna call this buffer. The init buffer and then data.buffer equals GPA dot alloc. Oh, we could do an aligned alloc. Would that help? No. Alloc U8 total chunks times video header times media video dot data per chunk. And then we do data dot buffer at media video data per chunk times video header dot chunk, so the chunk that we're currently at, dot 1280. And here's the problem: we do want to mem copy this, but we don't know if what we have on hand is the zero chunk or not. If it's the zero chunk, it's not gonna have maximum length. It's gonna be shorter potentially. So we're gonna need like a less optimized copy. So here's what I'm gonna do. I'm gonna split those things. So if video header, actually, if video header, like the ID is 0, we kind of want to do something different. Yeah, we might want to do something expedited. Well, we'll see. In any case, if video head dot chunk is 0, then we do the slow one, else we do the fast one. So the fast one is this. The first one kind of expects also length body to be length 1280. Also, maybe there should be a flag to mark something as corrupted, and then if it is corrupted, we kind of call it a day. Uh, Also, I think that we can simplify this logic to do less repetition, because we're gonna need also to implement the same up here. I think we can do something cute like if sequence equals meta the sequence, or sequence equals 0, then we do this stuff. And then down here we do if sequence equals 0, we do the initialization thing. Yeah, so this is going to start a new one. That is kind of cool, which is going to make us set the sequence number correctly, delete the old data, realloc the new data. Also, this should be done only if the length is insufficient. So let's do this. So if um, data.buffer.len is lower than, we need to know what the total amount of data is going to be. Total chunks times media, video, data per chunk, which we are actually doing a few different times. Might as well put it in a variable. Total size. If it's lower than total size, we do this stuff. Ooh, what about this guy? Do we resize it every single time? Do we resize it or do we keep it around even if it's bigger? Huh. Huh. Well, the question is, um, we have count, set range value, set unset, toggle, set all, unset all. We can do unset all if it's so if buffer length is greater than total size, then we reallocate everything. Otherwise, else data.scene chunks dot set all, unset all. We reset scene chunks. Okay. So this should get us at a point where we have initialized everything. Okay, now we want to do this. Does set return the old value? There's unset. There's toggle. Toggle set. Toggle all. Set union. Find first set. Find last set. Equal subset of. Superset of. Where's my like set get? Count is set. Capacity. Besides, oh, there is no get set. So I guess you first get and then you set afterwards. Okay. So if data scene chunks dot is set, return. There's nothing for us to do. This is a duplicate. Ignore duplicates. Otherwise, we set video header chunk. Replace the chunk where it needs to go. If it's 0, we're gonna need to do the more complete version, and also wanna do data dot last chunk len equals data dot len. Then we need to do the mem set. Also, if it's here, we need to do this. We need to like a kind of assert. Well, it's not an assert, but if the packet doesn't have the required length, it's bad. It's a bad packet. Actually, I think that the server should protect us. I think against this. Like if a client sends a UDP packet that says chunk ID different than 0 and the length is not maximum length, that's bad. That's a ban. That should force a disconnection, I think. So let's do that assert for now. Assert that if the LAN is 1280. Actually, it's not 1280. It's video, media, video, data per chunk. Okay. Oh shit, there's too much stuff called data. Oh no. There's oh no. Like video data. There we go. Last chunk length. Okay, then if we get down here and we have completed our mission, which we know because if data.syn chunks dot count equals, and this is the point of, do we compute the length, the total number of chunks? Do we compute the total number of chunks, or do we, let's compute it. Leave exact data buffer len. If it is the exact same, packet is fully reconstructed, ship it. So we ship it. How does it work, shipping it? Shipping it means pulling it to the very back, committing a write. So I think we do want our slot number. Yeah. We want to take our value, put it at slot 0, this is gonna be annoying. So if we do the plus equals 1 here, I probably want to defer this. Want to defer this. Okay. So we want, actually, we know what the first slot is. It's W. W is the index where W is the place at index in the indices where the first thing is. We kind of want to swap them with us. But how do we know where we are? We need slot. Slot is our slot. So I think we want something like, This now needs to become us. And indexes at and now this is going to be mask w plus slot. This is going to be the old first. So we swap our index with that one, and we commit the W. How do we commit the W? Commit read. Also, what I W here is license.index. Oh, this doesn't do the +1 for us, so we need to do +1. I think. Yeah. Oh shit! This is also wait. This is commit read. Well, where's commit write? Actually, that's what we're committing a write. Okay, you know what? Let's not ignore this. Let's take a look at audio stream, which has a form of committing write in here. Okay, let's double check. We know where the right index is. We look at the index that was there. We replace it with ourselves. We put ourselves at the new place. This W needs to be masked necessarily. And then we store mask to W+1. That sounds about right. Okay. Almost. Almost. Okay. So this is essentially it. This is a fully reconstructed packet. We can ship it now. Okay. Holy cow. That was right. Man, jitter buffers are always so intense. Holy shit. What do we do next? Next, so we have write. There's no restart. So here we have write. Now we need read. Okay, what does read do? Read looks at what it's available to it, which is again done via slices, which is this. Yeah. So that's the tried and true stuff. Thank God. So hopefully we don't need to touch this again. Hopefully we don't need to touch this again. Actually, you know what? Technically, this is suboptimal, maybe, because I'm just swapping my value with the oldest value, and I'm just taking the oldest value and placing it God knows where. Um, but we are not doing sorting. So by not doing sorting, what's happening is that, um, well, next time when we sort, then now we have to do the sorting work, which we didn't do here. You know what? I think that the sorting stuff in empty slices is unnecessary. I'm not doing it anymore. Okay. Okay. That, yeah, because this, the sorting would make sense if we did not do a linear scan here. It would make sense if we did not do a linear scan here, but uh, for now we are doing a linear scan, and I don't see this changing much anytime soon. We could do um, um, if it was sorted, we could jump forward, but it still sucks because you have a bunch of zeros. So yeah, I think this is fine. Okay, so I think this thing is done. The packet ring is done in theory. Your bugs aside, this packet ring is done. It's not 1280. I think this is a problem because if last chunk length is 0, then we need to cut it off. I think this needs an if. Mm, or we could do it like this. I guess an alternative way is media. Am I dumb? I think I'm dumb. If last chunk length is 0, Actually, can last chunk length be 0? I think it. I think I'm going off of a wrong assumption. I think last chunk length cannot be 0. I think 0 is an impossible value. I think length 0 is impossible. So we'll see. Mm, 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 mm. We will see. Yeah. Okay, no, but there is do-do-do-do-do-do. Can it be 0 if there's exactly one empty chunk that is the first and last? No. If there's only one, then it has non-zero length. The problem is I have a vague understanding. Like I'm getting confused a little bit by myself, but I know that there's something here. So the problem is we have. Now let me think about it for a second. We get us a chunk with ID 60. So we know there's going to be 60, or let's say 5. We know there's going to be 5, 4, 3, 2, 1, and 0. Yeah, no, you know what? I think this is correct. I think I was thinking of some compensation that I needed to do in the past. But yeah, no, I think this is not needed. So I think this is good as is. Okay. Okay. And actually, this being 0, I think it's even better than undefined. Very value they were assert against. Although, does it matter? I don't think it matters. Undefined it is. Okay, so does data need initialization? Yes. So we splat it, we splat this, we splat this. So this is all fine. Ignore duplicates. Ship it when it's full. Otherwise return error.full. Okay, so this guy is fine, I think. Packet ring is fine. Okay, let's go back to the jitter buffer as a whole. So jitter buffer. Our jitter buffer starts here. Um, so this is interesting because this is not a jitter buffer, really. Now that I think about it, what we did just now is not a jitter buffer because it it does collect stuff and then allows you to pull from it, but it's not exactly a jitter buffer because I'm realizing that this guy doesn't concern itself too much with timing. I mean, it does maybe to some degree, but it doesn't concern itself with buffering. So this is the point. There is no buffering concern in here. The buffering is a concern when here for the frame buffer or the image buffer, what do you call it? Frame buffer. Frame buffer does concern itself with buffering. But this jitter, this is not. This is the jitter buffer. This is just a buffer. And yeah. So what does the read side of this guy look like? Actually, what does the write side look like? So let's wire in the write. So let's assume that we keep this stuff around. So write packet. Okay, write packet needs to become write chunk. So write chunk, no restarts. Data is body. Um, we might have expectations about sequence numbers. Yes. Expect the next sequence number. So we do have this, definitely. We don't have restarts, but we do have the expected sequence number. Yeah. If restart is different than the restart, we don't do this. Let's oops. Okay, packets, write. Dropping video packet, video thread is too slow. That is fine. Okay. And then next packet begins. Function is meant to be called by the audio thread. All right, this is going to be the video thread now. The video thread calls slices to see what is available. Almost. Yeah, you know what? That is not exactly true. That is almost true. I think at this point, there is no point in handing over that. There is no point in handing over that um, frame if we have not decoded it first. Unless we assume that the video thread is not the GUI thread, it's a dedicated video thread that keeps pulling at regular intervals, which maybe is the correct thing to do. Yeah. Okay, so let's assume that the video thread is a thread, it's a dedicated thread that is not the GUI thread. It's a thread that runs with high priority that wakes up every 30 milliseconds or something. Um, and its job is look at the time, decide if it's time to schedule to set a new texture, to swap a new texture, right? Because we're gonna um we're going to make a texture. Oh, we are gonna need DVUI complicity for this. So we're gonna need something that allows us to make a texture, and uh, and then we keep it there, and then we swap it when the time comes. Okay, so that means that those packets also need something else. Okay, because in all of these we're missing the decoder work, which we're gonna have to do as well. Okay, give me a sec. I'm gonna refill my teacup, and I don't know, we continue. I think that my optimism about being able to pull this off in one sitting a little bit misplaced, I fear. Oh well. Okay, a second, I'm ready. Okay. Next packet begin. Next packet begin. Right, because we get access to it, but we don't commit we don't make it available to the writer side until we're done with it. Who should schedule this thing for the coding? It should be us, because the writer side has no knowledge of what is appropriate to send to the decoder or not, because the decoder is stateful and you can't just decode random stuff. So if we are forced to do a jump forward and decode garbage, we need to do so knowingly. Okay. So that means that here, when we do slices, I guess we kind of want two slices. We want hmm. Okay. I think we can have one assumption. We can have one assumption. We must assume that the decoder is able to keep up with real time. That is what we must assume. And that's a safe assumption, because if the thing cannot keep up with real time decoding, then the thing is not going to be able to show us any kind of like video playback. So that is a requirement. So that means that if it has to keep up with real time and we do double buffering, we're good. We're good, because what we do is that essentially there is one frame out there ready, and all we do in here is schedule the next one. And we run everything with a one frame delay. Okay. So our goal with slices, so here our goal with slices is to, yes, on this side, so never mind. On this side, we do have jitter buffer concerns. We do have a concept of buffering, yes. Um, Oh, slices has a dot array. That's convenient. Okay, so we decide to do the buffering, whatever, fine. Then we come here, and now this is going to be very different though. So I guess the question is, do we want the decoder to swap out a frame for us or what? What do we do with that? No, I think we need a callback. Hmm. Huh. Well, okay. Also, I'm going to remove logging. Let's simplify things. So, oh, here I'm calling this n and this idx. Let's call this slot. Um, Actually, idx is not that bad. Index plus idx. That is kind of ugly. No, I think slot is fine. And then n. Oh shit, search symbols. I think this should be idx. Okay, with these I've aligned nomenclature for these things. Okay, so the question is also, yeah, jitter buffer. So there are no restarts. Sequence number. Expected a sequence number. We expected a given sequence number, but we got something older. We moved past it. This is stats. We don't care about stats right now. Okay, we found what we expected. Increase what we expect. Commit any old read. And this returns playing this data back. All right, this is not a thing. There's no, okay, there's no dread. I wish we had dread, but we don't have dread. We only have starting. So when starting, we should play a loading animation. Maybe. Contains a compressed opposed. So this should be contains a frame to the code. Which, by the way, who are we returning this to? The video thread? Yes, we are returning this to the video thread, and the video thread will schedule the decoding. contains a video frame to decode. And this should return a packet ring data. Yeah. And then there's no dread. I wish we had dread. Instead, we don't have shit. So we're missing a frame. So if we are missing a frame, what are our coping strategies going to be? And the answer is I don't know. I don't know. Okay. The fact that there is no FAQ um and no dread actually makes this jitter buffer significantly simpler now, because we have the right one. So we see something old, skip it. We see something right, ship it. We don't see something right, return missing. Like literally. Literally just return missing. And if there is something to commit it. That's it. That's that's it. None of these can happen. None of this can happen. None of this can happen. None of this can happen. Uh, Actually, we can fall through here. And then we look through the full buffer and only found all data, which means we're back to buffering mode. Yeah, which is essentially this. So buffer underflow, return missing, commit read, commit everything as red, increase the expected next thing, yes. State to buffering and return missing. Yeah, it's good. Oh man, this is so much simpler. Holy fucking shit. Uh, um, okay. So this is the jitter buffer. Now here's what we're missing. We're missing a high priority video processing thread. So there is no frame buffer because we can't afford to have that really. Or rather, maybe we could, but we're not going to do this. At least for now. So we're going to have a jitter buffer. And we're going to have a future for our video thread. A feature that returns what? Mm, Hmm. Mm, mm, mm. No, okay. Video thread. It's a future. Do we make it optional? Do we make it optional? No. It's a future, and it has what's gonna be its error set? I don't know. Any error, void. We don't really care about what error it returns with, at least for now. Okay, so this is the OS. This is video thread. Is going to be, so we need IO. Video thread is going to be IO.concurrent. Video thread arguments IO GPA C first frame data maybe. Do we make it hold the decoder? Oh, in theory, we could have the thread hold the decoder instead of keeping it here. But this is a more familiar structure, so fine. There we go. IO GPA C. Actually, this should be C IO GPA. So that it looks like a method of this guy. Uh, okay, video thread runs as a high priority thread. Uh, pulls at regular intervals from the jitter buffer and swaps at the right time the video and and I think that this should call the VUI when it's ready. Whenever we do a swap, we call the VUI. We don't have the VUI run on a fixed schedule, I think. So that means that we can take out the timer from the VUI. The assumption, though, like for us to be able to do this, though, I believe I might be wrong, but I believe that we might need the ability to create textures from here, and I don't know if we have that ability. Okay, so the texture stuff is the stuff that I'm not fully clear on yet, but the rest kind of makes sense. So from the jitter buffer and decodes and schedules. and schedules the code frames to the UI, something like this. Okay. So this is our consumer. Also, this is a pretty important try. Okay, so first thing the video thread should do is set up a high priority. Awebo network utils, set current thread real time. Although the settings here might have to be different. Time equivalent to an Opus packet, 20 milliseconds. Yeah, this is not the same. Period MS needs to be parameterized. At the very least, maybe we should parameterize more, but like this at the very least needs to be parameterized. So real time period MS view size. And so here, if it's so 30 frames per second is what? Every 33 milliseconds we must run. Something like this. Oh my god, are we gonna run just ever so slightly faster than we should, because running at the right frequency is like essentially impossible. Well, no, it doesn't matter, because what matters is um what matters is so this is gonna be every 30 milliseconds. Period MS. I think we should parameterize maybe even more. 30 ms. Estimate 20% of period needed must finish within 30% of period. Okay, for now, let's leave it at that. So I think this is like every 33 milliseconds we need that that capacity. Okay. Then also this is network utils, but turns out it's not just network that needs this. I'm kind of weirded out by the fact that we don't have a OS thing that gives these to us, but I mean, what can you do? Okay, so set to contrast real time. Then from here we pull from the jitter buffer. So actually we switch. Next packet begin. And it's gonna be start the code and missing. Okay, if it's start, I think we literally do nothing. We do io dot sleep. Duration is, oh, you know what? We need a while loop also, and we kind of want like a start time. I guess we can worry about that later. Okay, so while while true, or even better, while true, semicolon. Mm, so sleep 33 milliseconds, awake. Okay, missing. Actually, the code I think should be like this. So duration is gonna be from um I guess there is a numeric trick to avoid any skew. Basically, you probably want a checkpoint that um we can worry about that in the future. So we want to make a duration. So it's start dot s duration to add duration, which is gonna be in nanoseconds, and nanoseconds is gonna be sd.time dot ns per second divided by 30. Um, wait, what's the correct clock? I have it in network. What's the correct API? Do. we make a timeout and we do timeout.sleep. Okay. Okay, so if it is the code, we do this. Also, this should not be like this. And this should be comp time unreachable. Okay. And then in here we do we schedule the decoding. Actually, we could wake up this, you know what? This thread could wake up more frequently than you could actually wake up at twice the frequency, which would give us more headroom for earlier decoding, but that would mean that we give less time to the network to get us our data. We don't want that. I think we really want last minute decoding. Yeah, let's keep it as is. Okay, so in here, if we have a frame to the code, great. We set it to the coding. So this is going to be vs dot push chunk, push image. Let's do the code. The code packet. Dot slice. Okay. And that's going to be ready at some point on its own. Um, who does the swapping though? Okay, that part is not fully clear to me yet. So uh, let's clean up some more stuff. Oh, so actually this can be, wait, this is a OS thing. vs.os.decode new frame. There we go. Data and then keyframe. Oh, we forgot if things are keyframes. d.data.keyframe. Now we need to write that down. So we create a new thing. Method.sequence is this. Uh, data.keyframe equals video header.keyframe. Okay, was it because it was an optional? Yeah. Okay, video header to keyframe. Uh, okay. So we have this keyframe information in there. Then now we can go into our packet ring is now an ambiguous reference. Oh, because there's this, which we don't need. Okay. So these are the keyframe. Perfect. So it seems that we don't need GPA in here. That's fine by me. Okay. Then the next thing is we need to take the last decoded frame. We need to swap it in, but let's start by looking at the what this callback triggers. So this callback, yeah. So this gives us clock. This gives us good clock, and now the callback. So we actually do need frame in here, and we need to be. But I think it can be a std.atomic dot. Let me think. So um, I think we can keep frames here if we want to, but is that what we want? I think so, because if we don't keep a frame, then we're gonna need to copy these values. We could turn them into textures early. Yeah, that's the question, right? Because previously I had this value, and then it was a frame, um, which I think I might even have deleted from this code. Well, this guy is still here. Yeah, I think I've deleted frame, so I'm gonna have to bring it back if that is the case. But in any case, that's not a big deal. Screen capture has this code, so it's essentially this. They need to be pub. Maybe yes. I don't know. Or no, wait. I guess one way of doing it would be that we do this. And well, dummy also needs a frame. You know what? Dummy can fuck itself. get fucked for now. Okay, so where's the callback? Uh, so, all right, this is the one that we killed. That's fine. Function with callconf that the OS can invoke whenever a new video frame is ready. Right. And so we guess it was either we put in there a frame or we put in there pixels directly, but either way, oh no. And I remember the problem is that if we put pixels directly, then we lose a handle to the thing that we need to destroy it. So might as well just keep the thing around. Okay, so this was frame. Was it a pointer? Actually, let's look at screen capture because I don't remember. How do we do it here? Optional pointer to frame, right? Okay. Okay. Um. Actually, this shows that swap frame should be implemented in OS more than up here, maybe. But anyway, so with this we have swap frame. I'm gonna move this up here. Okay, so this is swap frame, and this puts a new frame in there. Then here we have this. Okay, I think we are essentially there. I think we are essentially there. Okay, we should not be too far from the general stuff working. Let's see. Empty slices, packet ring, and this is called PB. There you go. Okay, next problems. Ignore duplicates. Data isn't an identifier data. Mm, right. No, because here I have const data this. Well, I can do it here. Move it there. Video header. Okay, next problem. Right chunk. Body. Okay. This is now kind of gone. Full chunks, last chunk data, data. I don't know where we're using these anymore. I think we're just not. Okay. Okay, let's go to network and let's wear this in. So let's stop whatever we're doing in network, such as no more video buffer. Oh, right. There's also the point of we need the first thing to be a keyframe. Uh, who is it that needs this? It's a jitter buffer. That is actually interesting because when we are starting, we need to ignore non-header, non-keyframe. Okay, so that's the thing that we need to do. It's going to be important. Okay. Nothing found, blah, blah, begin read. Audio stuff is fine. Begin read, screen capture packets. Wait a second. Oh, this is the media sender. Yeah, and that is fine. Okay, we need the media receiver. Where's the media receiver? Media receiver. Want keyframe? Want new frame? No. Screen frame next chunk? No. Okay, screen. Data. Begin on a new frame. I think we literally just don't do any of this stuff. We literally do none of it. Almost. Where's the thing where we instantiate a new this? There we go. Color screen equals null. If screen is not a keyframe, continue. That's not our job anymore. If it doesn't exist, we create it and we pass body. Oh, but wait a second. We can only do this given how things stand right now, we can only do this. Okay, you know what? The thing that I mentioned about this not being our job, yeah, then for now it's going to be our job for a while. So if it's not a keyframe or not screen dot first of chunk, then we continue. Also, why are we parsing screen? Oh, because we need to know this. Crap. No, it's okay. We can avoid doing it. And then we do this. Create this with body. Push chunk. Sequence number. Body. Oh, here we also need sequence number. Okay. Oof. Okay. We can make this nicer, I guess. And this is because we changed the API a little bit. Okay. This is fine. Let's take a look at the create function though, because now this has to be different. Oh, this is not video caller anymore. This is now a video stream. Sequence number. And then body. And here we need to do this for now. We need to parse this. So we need to do wait, we got, how deep do we go before we actually read this stuff? Here. Okay, and then we do if video header dot, if it's not first of chunk, or if it's not a keyframe, we return null. And this returns yeah, for now that's how it will have to be. And actually, no, here we want video data, not the body. Perfect. And after we do this, we want to push chunk. Okay, push chunk. Do we call it correctly? Push chunk in here? Yes. Okay, so we fixed this. I think there's some more stuff that we need to fix. I don't think this is enough. Um, yeah, like these arrows here. Oh, why is this stuff in screen capture? Packets? No, no packets. Init capacity? No, no. Swap frame, maybe, sure. Encoded video frame push. Oh, this is packets. Oh, it's outgoing packets. Shit, never mind. Okay, I get it. So this guy we don't need. And in here, these goes here. Okay, because it's a capture packet. Oh, okay. Maybe we'll have to share this in the future, but not now. Hmm. Client media video stream macOS has no members. Uh, oh, what? What the fuck does that mean? Wait, what's your problem? If macOS has no members. In video stream, we don't have dot frame. Yes, we do. macOS dot frame. What's your problem? Has no members. Okay, I need to see this. Client media video stream macOS. Oh, it's a pointer. I guess because it's a pointer, it doesn't work. Oh, because it's a pointer, it doesn't work. So I guess the alternative is that we make it a struct. What happens if we make it a struct? I guess that's fine. Okay, are you done complaining now? Especially when argument found 0. Yes, this is the 20 millisecond one. Push chunk. What's the problem? Really, there's no push chunk there. Oh my god, don't. There is. Wait, what's the problem? Push chunk in client media video stream. Function push chunk video stream. But oh, bro, what? What am I missing? What am I missing? Client media video stream doesn't have push chunk. How am I fucking this up? I feel like I'm getting memed by Zig now. Maybe we should look at other errors first. No field reflection name push chunk in client videos media video stream. Method invocation only supports up to one level of pointer dereferencing. Oh, right. Of course. When it's like this, it's because of this, of course. Oh no, now there's a bajillion errors in my jitter buffer. Expected media video stream request found pointer to right chunk expected fragments found to GPA. That means that this is a try, actually, and this is an erroring function. So that means that this is a try. That means that this is an err defer gpa.destroy. This. And this is a err defer os.dinit. So actually starting this before we initialize VS might be a problem. Okay, some things are a little bit better now. Wait, no, well, we were able to do try below. Yeah, no, we are able to do try here. So never mind. So this is indeed a try thing. Right chunk is void. Right chunk is void. Right chunk cannot be void. Oh. Ooh. Ooh. Okay. Missing packets. Yeah. What about this jitter buffer? How do we initialize it? How do we initialize packet ring? Does packet ring need an proper initialization? Doesn't seem like this. Hmm. Yeah, this is kind of ugly, but this is another thing that can fail. That sucks. Oh, but we can return So you know what? Let's just try this stuff and return and let's do proper resetting. So, hmm, 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 The union tag, blah, blah, blah. What? Next packet begin. Starting the code missing. Oh, W32 found U size. We change the buffer. Yeah. But in the code, we're gonna need to know if it's a keyframe. But it is in data. Never mind. That's a problem now. We're wasting a with clock. Happy now? No. Expected type clock duration. Oh, wait, this is not duration. This is deadline. Okay, there's another bug in this code because this is not the original starting point with this. It's this multiplied also um by the sequence number. We know the sequence number. Let me think about it for a second. Do we know the sequence number? No, we uh I think it's like this. We need a counter. We increase frame count by 1 and we sleep from the start to this times at duration. So the duration is, where do we do the multiplication? Do we take this quantity and multiply it multiple times? No, I think we take time, nanoseconds per second, and we multiply them. And as per ms. I think this should be fine, right? We do frame count times this divided by 30. Hopefully this help us stay on track. Yeah, it should. Okay. We're not quite there yet. Okay, I'm realizing now that the frame handoff is wrong. So we are like 90% there, minus some bugs, but we're missing the, like, this thread needs to be the one that does the swap. We schedule stuff for the coding, yes, but we do the swap first. Okay, I'm going to refill my teacup, and then we set up a proper correct swap. And then we test this stuff out. Like at this point, everything that is left is bugs that we left around along the way, and that's it. Hey Julian, hello. It's willowing my ptarmigans. I am almost done implementing the video jitter buffer. First pass, I have to go through, the basically through the whole pipeline and resolve every bug that I left along the way. The only thing that remains here is to have this video thread do a frame swap at the right moment, and we're done. So again, minus potential, but also kind of guaranteed bugs along the way. So yeah, I'm gonna review my teacup, and then let's see if we get a satisfying payoff or not. I'll be right back. Okay, so let's recap. Mm, the code new frame, I think we can call schedule decoding. Okay, so that it's clear that we are not doing the work right away. Schedule decoding. So before we schedule the coding, we do the swap. So we take the frame that we hope was produced in the meantime, and we make it available to the UI. And we refresh the UI, which we currently cannot do, but we will be able to do in a moment. It's more like vs.refresh UI. Refresh. Okay, so now we have the question. Can we make textures on our own? I don't know how those things work. So DVUI. Hey, Adam the Cable, thank you for the raid. Hello, everybody. So I'm implementing a jitter buffer for screen sharing. So yesterday I got screen sharing working, but it was like super jittery because I was just rendering frames to the screen as soon as they arrived. And it turns out that you have jitter even when you're testing this stuff locally. So I didn't even attempt to test it over the network. Even with the loopback interface, that's enough to have some jitter, at least on macOS. Like multiple milliseconds. Like it seems weird, but there's like I think I've seen 7, even 10 milliseconds worth of jitter in my local system, which is curious, but it is what it is. And so that made the video wonky. So we need a jitter buffer for the video stuff, and that's what I've been working on today. Didn't you already write a jitter buffer for audio data? Thank you for asking. Yeah, that is. You would hope to be able to reuse the same data structure, right? Well, what I found out is that this jitter buffer has to be very different because it's simpler because it doesn't have to worry at all about any of the packet loss stuff. So in audio, whenever the next packet is missing, you can look at the packet right after, and you can use the deep redundancy information to play something. And so the jitter buffer needs to do essentially this look ahead. For video, as far as I'm aware, there is no such system. So if the current packet is missing, it's missing, period. And so all the look ahead logic completely cut out. Then on the other hand, though, audio data has one UDP packet that produces one packet worth of data. But for video, we have to split. We need to chunk up our video frame, our compressed video frame, into multiple UDP packets. And so we need to essentially have code that collects those things and rebuilds them into a full packet. And that makes the jitter buffer all kinds of weird. It makes it weird in all kinds of ways. And so they don't share an implementation right now. Yeah. Okay. So let's see. Well, I think we found our answer. So we cannot create a texture if we are not between window begin and window end. So we're not able to create textures at will. So that means that we need to do double buffering with frames, which is fine. I do wonder if the latency problem is something to do with default buffer size for POSIX sockets. I have no idea. I don't know. Uh, so what does that mean? That means that we have two frames. So we have the back frame and the front frame. How do we call back frame? Frame. Let's do it the other way around. Frame back and frame front. Okay, this is my first time implementing double buffering. I mean, I understand that it's not a super complicated concept. I just never done it. So let's see how this goes. Okay, so schedule the coding. When it's done, so swap frame needs to accept like an enum that says if you're swapping front or back. I guess we can rename this to swap back frame because that's the one that the CAPI cares about. The CAPI does not swap the front frame. So frame back swap. Okay. And then there's swap front frame. So this is called by the UI thread to stuff this frame, well, to make a texture out of this frame, to update texture out a texture with this frame. Yeah. Yeah, have a good day. Okay. Okay. So we have, so this is mostly there. So that means that in here we want to swap the back buffer with null. And we want to swap the front frame with the back one. And then, and actually, I guess we can do this so that we don't create temporary variables. If front, I think we want some logging. UI did not consume front frame. It's a warning. Okay. And then here we call refresh, which we currently don't have. So here refresh. Do we have core? Yes, we do have core. It's a core dot refresh function. Oh shit, we killed we killed flow. How much did I lose? Okay, I didn't lose much. Thank God. Um is this a function pointer? Is this a function pointer already, or is it just a function definition? It's a function definition, so this needs to be a const pointer. I think a create might as well just get core. Also because this function wants core. So you know what? We just need core at this point. We need core. Or we don't. No, because the video thread needs it. Never mind. Yeah, we need core. Yeah, I had a flow crash, but I think it's the same. It's the usual stuff. It's the same that you had before, like when the LSP autocompletes a function definition in the wrong way, and then I try to put it on a new line, and something goes out of whack. It's an old crash, not a new one. Um, it's the one that I believe you said that it has to do with Ghosty giving you wrong information. Yes, you did. You did manage to reproduce that. It required precise keystrokes, but actually, I think that the conclusion was that what was crashing was either these or the inline errors. It took you a while because it required like precise movement, like just doing the general movement, but like the cursor needed to go to the left like 1 or 2 squares, something like that. Now this has only one issue. This has only one issue. If we have a missing thing, there is one more frame that we could play, and we don't play it. But we can improve this later on. Save the session idle. Um, no, that is fine. I prefer to manage manually when stuff goes to disk because sometimes I like undo, then save, then redo. Like I do sometimes play around with what's on disk and what's in memory. So I prefer this. Oh, you're saying it doesn't save to this to the original file. It saves to the. I see. I see. I see. Um. Ah. Hmm. Um. Hmm. I'll think about it. Thank you. Okay. Now we need to fix all these calls. Okay. So now there's no swap frame. Okay. So now we're in the UI. Um. Now we're in the UI, and there is no timer anymore for this. Actually, wait a second. No timer for this anymore. Hmm. But we do want this. We don't do any of this anymore. Okay. Swap front frame. I fed 3 arguments. Right. I think we might be compiling at this point if it's taking this long to fix the error. Or maybe not. It's actually taking too long. Um, what's going on here? Oh, undefined symbol frame get pixels. That is fair. Right. This we is the last place where we need to fix this. Okay. We have something. Let's see. Let's see how it goes. Oh, we're dropping hard. Dropping video packet, video thread is too slow. Oh shit. We're going kind of crazy. So things are not going great. Oh shit, my computer is dying. Force quit. We tried. Okay. Um well, we need some logging to see what's going on. And it all starts, I think, with the jitter buffer where we need to write down um our progress. Like we need to write down what's happening with our chunks. So video stream. Packet ring. Yeah, so this is where our adventure starts. Actually, I have already written this. No, but it doesn't apply much. It's unfortunate. Okay, let's see how far we go. What are we doing release fast? I don't want release fast. Okay, we're not doing great. Somehow we are failing. We're failing to put anything in the right place. Somehow. Chunk ID 0. Padding equals. Okay. Um. Okay, I should have started putting stuff at the top, but yeah, we're doing not great at all. Not great at all. Let's print also data len, video chunk, video header. Okay. Let's print this from the top and let's see what happens. We're failing to put this stuff anywhere, so that's kind of bad. That's a really big bug. Blah, 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 blah. Okay. Okay, let's see what happens. Product data out. Decoder session created. Hardware. Perfect. Video chunk. 43. First chunk true. Keyframe true. Padding, whatever. Okay. So this is a good chunk. And somehow these are all the empty spaces. But somehow we're dropping it. Like, what the fuck? How are we not getting into any of these guys? Dropping video packet. So this is what we print. Wait a second. Actually, where do we print dropping video packet? Video thread is too slow. When this returns an error, so we are returning an error from this guy. Okay, somehow we're returning with an error. I guess usually an error it means that we failed to allocate something. It's only out of memory at that point that can happen. Like that is not a com- complete bug. With error full. Okay, so somehow we're returning with error full. But I was about to say, but maybe my empty slices are empty. But no, we print all of them. We print them, so there is a ton of space. Oh, that's the problem. That's the bug. There we go. Okay, let's see where we hit the next error. Integer overflow. Integer overflow, my friend? Come on. Video header.chunk 43. Video data per chunk. Oh my god, this is overflowing because this guy is a U15 and this guy is a com time number. So it eh, okay, let's make this a U size. I think this should help. I'm not entirely familiar with the integer promotion rules, so I'm gonna try it out. Okay, nice. And that is actually correct. Yeah, I actually, for a brief moment, thought about it. This is wrong. This is um, media.video. I think we should make it a constant at this point. Okay, so these should be fine. Nice checks, by the way. These nice checks are saving us from yeah, potentially annoying trouble. Okay, great. So sequence one, chunks 44, keyframe through. Also, why is this always 0? Wait a second, why is this always 0? Wait a second, why? I just noticed. Why is that always 0? What? No, 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 no. What's going on here? Wait, more below. Um. Oh, right. These indices, they do start all at 0. They do start all at 0 indeed. They do start at 0. The problem is that, yeah, how do we solve this? It's kind of an init step that we would like to do, I guess, instead of doing a init like this, maybe. What's the bug? The bug is that somehow I was expecting my indices to initialize to map nicely, but basically these values are all 0 at the beginning, and so they keep indexing, all of them index to the same slot, which they shouldn't, or rather, it was fine before, but now I'm using this jitter buffer in a weird way. Actually, before the jitter buffer, the ring buffer is being used in a weird way. So yeah. I was annoyed at um PAVU control. What's PAVU control? So I think we need an init function. We don't do much in it, but we do need an init function. Either that, or we actually no. We don't need an init function. We can do it at comp time. It just cannot be a splat. This cannot be a splat, but actually this one. Oh, pulse audio volume. Okay. Okay, does anybody know a better way of doing this? I don't think we have a more concise way of doing this, right? Oh no, this guy is still running, eating all my memory. Shut off. There we go. Perfect. So sequence 1, chunks 1, keyframe true. Sequence 1, chunks 2, keyframe true. Chunks 3, keyframe true. Okay, so this is all good. And at some point we should have all the chunks. 7, 6, 5, 4, 3, 2, 1. So now in theory, 40, 41. Okay, now in theory after this, our list of free it's not free because they're not really free, but our list of slots in front of the right buffer, or rather between the right index, between the right index and the read index, now the right index should move forward by 1, and so we should start with 1 from the next print. Will we start with 1 from the next print? Of course we don't. Of course this motherfucker is still here. God damn it. Okay, we need a print to see why we're not why we're not committing this thing. I bet you that the math here is wrong. Okay. One off by one error at one off by one error at a time. We're gonna make this work. Okay, we instantly crashed this time. Let's see what happened. Oh, right away. After redo header, first of chunk. Oh, I think yeah, I think we that's unfortunate. I think we got uh timed. So there's yeah, there's a to do thing that it's causing us to have issues if the thread starts too late. Oh, come on, really? Again, we're getting timed? Wait, no, this is a different bug. Scene 1, total 1. Well, what? Oh, got base failure. Okay, never mind. No, actually, there is no timing thing. I was wrong. Just copy paste failure. Okay. I let it go way too long. I'm done. You know what? I'm not gonna do this. Let's just restart. Okay, let's see. Total is 49, 45, 2. No. What is this? What? What? What's going on? This math does not check out at all. Also, this guy is still running and it's like killing it's killing my poor ghosty history. Man, it's almost like I'm running the cloud code agent thing in my terminal. Why is this number so huge? What am I doing wrong? I feel like I'm going crazy. Wait. LAN max data. Oh, 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 oh. I know what it is. I know what it is. It's me being too stingy with data. No, we need to cache here total count. That is on me indeed. Okay, let's see if we reach that print now. Man, I let it run for like a brief second and it immediately blasted through everything. Okay, so this is the first packet. 9876432 Also force quit so that you stop eating my stuff. Packet ready, submitting it. There we go. And then we go here. Oh, this is delightful. This is delightful. Chunk 1 versus chunk true, chunk 0 versus chunk false. Move it here, ship it. Packet ready, submitting it. This is a zero. Oh, this one is interesting. This one is a zero packet. So this is already done. Let's see if we submit it right away. Yes, we submit it right away. Boom. Boom. Packet ready, submitting it. Okay, we're submitting, and then we're getting the code errors. Now, why are we getting the code errors? Who knows? uh, okay, so that means that the jitter buffer should be kinda okay. No, I know what we're getting the code errors. There is one last mistake that I made, which is how we compute what is the corrected data. That happens on the reader side, in the jitter buffer here. No, it's not in here. It's in here. When we compute the last chunk len, yes. Okay, so where we use this information wrong, which is here. Yeah, we compute this slice wrong. Okay. This slice is computed wrong. We have the total number of chunks. We have the length of the last chunk. So we do. So this is going to be 0, 2. total chunks minus 1 times it's max data, but let's call it media video data per chunk. Okay, you know what? Might want to put this into an expression. I think I have a wrong assumption. I think that occasionally the last chunk could be empty, and we're not doing this right, but it's okay. Okay, let's see what happened here. Nah, Jesus. Okay, here's what happened. What? Oh, somehow I pasted code and that spawned. Is a pseudocode? No, thank you, dude. I don't need anything. Okay, close. Force quit. Let's see what happened. 26, 24, 23, 22, 15, 10, 9, 8, 4, 3, 2, 1, 0. Okay, so far so good. Debug, no texture, no texture. What about, okay, we still have the code error. So, so to make sure I don't mess up the math, I think we need to print the length of this guy when we put it in, when we send it in, and when we read it out. So somewhere we're calling slice. Let's print the length. Let's use warn. Um, the code data length is going to be this, and we need also the producer end, which is in screen capture. We must already have those prints. Screen capture. Well, yeah. Do you have any good print in here? No. Let's add it. So len is the actual len. So log dot warn encoder len equals len. Okay. Oh, we even have a sequence. So we can even use this. Where do we increment the sequence though? Oh, up here. Okay, that sounds good. Okay, so with this, we have a print on this end. Now we have a print on this end. Let's see if we can do a sequence number also in here. No, we don't have the sequence number, but we have frame count. We have frame count. We just need to start it at 1, I think. Does that make sense? If we do that, this needs to go here. Okay. Okay, so we start with this. 26, blah, 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 blah. 14, 10. I think I might as well remove these prints here because we can trust them now at least a bit. Also, wait, we need to remember what was the length of this packet before we scroll down. So what was the length of this guy? 41,868. 41,868. And then there's a second one. Okay, we'll see that in a second. Encoder, 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 encoder. Decode. 41,868. 1642, 1216. I think the lengths are right. 1216, 1642. 1642, 1216, 1287, 1287. So we're not doing it wrong? So why are we getting the code error? 12909. Why? So is the data somehow corrupted, maybe? I guess we could hash it and see if the hashing prints the same on both ends, but um okay, let's reduce the amount of printing from our packet ring. Where is it? This, comment it out. We don't need it anymore. So 12909. Let's take a look at that as well. 12909. 12909. Bad data. Okay, so I'm guessing we're messing up. We're messing up something relative to the data. What precisely, I actually don't know, because now that I think about it, we haven't really changed this stuff much. Although, I mean, yeah, well. Yeah, you know what we're doing? I think I know what we're doing. In the jitter buff, well, the packet ring, let's see where it is that we're placing this data. Yeah, we're placing where the chunk says it wants to be, except that these chunks are all backwards, so they're meant to be this is like this. They need to be backwards. Yeah, we were basically writing the data scrambled. We were using like I don't know what to call it. It's not little endian, it's not big endian, it's like scrambled endian. Let's see if this is any better. Okay, let's see. 41863. Packet ready submitting it. Where's the decoder? 41863. Oh, now we have a 12704. We have a new error code. What the heck? 12704. That's that's not even an error coding here. Dude. Oh man. 12704. Hmm. 12704. Uh I think we are scrambling this data a bit. I think we need hashing and we need to descramble it. Like there's probably some other mistake that I'm making. Let's see if there's an easy way to print the hash of this stuff without going insane. Screen capture. We have this. Hash, auto hash strat, int. I don't know, good old CRC. There's a bunch of, I guess there's a variety. What the fuck? How many CRCs have been invented? Okay. FNV1A. Hash. Input. Data. 0.len. No, now what should be completely fucking different on the other end? Like completely incompatible. Um, okay, I'm going also to remove in video stream. There's a print that we do in every time in here. I'm gonna remove this as well. So even less spammy. Let's see what happens now. Yeah, that's something that I haven't handled. Okay, join. Okay, encoder. Um, shit, I pressed down. I should not have pressed down. Fuck, that is on me. Can I search? Can I ghosty search? Oh man, ghosty trick. Okay, decode. Well, there we go. Hashes don't match. We're messing up. We are indeed messing up the way we do this stuff. I think I'm missing a +1. So it's max data times total chunks. If it's, for example, if it's chunk 60, you should go to place to buffer. What should start at index 0. If it's chunk 0, it should go to the very last. Yes. If it is chunk 0, it should go to the very last. I guess we can hash each chunk and see if somehow they get corrupted, but yeah, you know what? I think it's this. I'm gonna make this better. I'm gonna fix this at some point, but for now, I just want to make it work. Hey, Daniel. Hello. Hello, Coca. Okay, let's see. Oh, well, I think we have our answer. It's working. How do we know this? Because we printed something. Now, here's the problem. We printed the first frame and then nothing is working. So something went out of whack afterwards. No, anyway, but it's a different bug at this point. Video stream packet returning with error full. Dropping video packet. Video thread is too slow. Okay, so things were going fine in the beginning, and then we started going, well, not fine. Okay, so we have fixed. This could be better. I will admit that this could be better. I will take full responsibility over the fact that this could be better. Okay. So then what is going wrong next? I think that what's going wrong next is that we are sending this stuff to, well, first of all, is the reader committing their reads? Do. Oh, you know what? No, we're not. We're definitely not committing our reads. Well, shit. That is a big problem, isn't it? Um, oh, but we can't because we're not doing this in a blocking manner. Okay, let me think. The fact that the coding is not done, it's done asynchronously. You know what? I think that this should not be this should not be asynchronous. I think this should be synchronous. So the code new frame. I think this should be synchronous now. And and then once we're done, we do d dot actually we do vs dot packets. Next packet commit. D. Yeah, we do this. And then that means that in here, we do not turn on asynchronous decompression. We'll only do the other one. Let's see how this goes. Oh, it worked for a brief moment and then it pooped itself. Okay, so we're still pooping ourselves. But for a little brief moment of happiness, we had the video feed. So what are we doing wrong next? What are we doing wrong now? So now we are committing the packet. So I think we can get rid of the hashing because that's not a problem anymore. So let's go to screen capture as well. Get rid of this. This is not a problem anymore. So what is our next problem? I don't know. Let's see if the logs tell us a story. Actually, you know what might be happening now? I think I want to restore the ring buffer printing because now I want to see the ring buffer actually do ring buffer stuff correctly. So let's see if that is happening as it should. Okay. So essentially, oh, I eliminated the other prints. That other print would have been nice in combination with this one. Oh well. So sequence 1, 37, packet ready, submitting it. Packet ready, submitting it. Packet ready, submitting it. Is Zig async built into the language? No. Zig's async is um, entirely a standard library concept. It has privileged interaction with, for example, main, in the sense that if you're using juicy main, you're getting a like an instance of IO, and it's an interface that you're supposed to use that is like all encompassing in the standard library. So in that sense, it's kind of like a reader and writer, but it's not a language feature. There are some language features that um, that currently we don't have that will interact with async and make it nicer. But those will be like compiler features, I guess, more than language features, in the sense that it's something that the compiler will do for you rather than. Actually, you know what? No, I take it back. So there are two features that I was thinking about. One is computing the size of green threads, and that one is not a language feature. It's just a nice compiler feature. So you're not gonna do weird syntax stuff for that feature. The other one is stackless coroutines, and never mind, that one is a language feature, and I'm imagining there will be new built-ins for it. The limited continuations. If by the if you mean that in the sense of stackless coroutines, then yes, that's the second feature, and that one will have a like an impact on syntax, but nothing crazy. It will essentially just be it will actually be less syntax than what normally you would have for stackless coroutines. In our case, it's just going to be essentially built-ins that do stuff like suspend, resume, and frame size. I'm guessing that kind of stuff, more or less. I heard continuations are powerful as monads. I don't know. I think people like too much fucking around with these abstract concepts, like with these concepts in abstract, and then they never bother to make a good implementation of them. And the end result is that people conflate asynchrony with concurrency when they shouldn't. Okay, so I think what is happening, the fact that we see a few the fact that we see a few frames and then it freezes makes me think that the problem is that we are not de-initting we are not de-initting frames when we should be de-initting those frames. I think that's our mistake. So question number one, do we do that in the GUI? I believe so. Yeah, new frame. Whenever there's a frame, we call the init on it. Do we do the init in video stream? In video stream, when we swap, where's the swap? Here's the swap. We swap the back frame with null. We swap the front frame with the back frame. If this was not consumed, we de-init it. So what remains is that the Objective-C code might be doing the wrong thing. Decode the frame callback. There's a drop frame. Okay, we have a print, but um, but I still don't understand what's going on. So let's mute some of the more spammy. No, actually, no. I don't want to mute the more spammy stuff. I want to see if this guy does the right thing. So let's re-enable this print and I don't know, do another round and see what happens. Oh, shut up! Shut up! Shut up! Damn, I wasn't fast enough, and all my history is gone now. Let's see what's happening. But we can see at the end that what was happening is that this is now full. I think this should tell me if if these chunks are full. Well, no, they're not full because, oh, you know what is happening? Maybe I think what is happening is that these guys have length 0 in the last packet, and that is causing issues. Although we do have an answer for it. So no, we would be tripping an assert if that was the problem. Yeah, we would definitely be hitting an assert. Are you on the latest macOS update? I feel like NeoVim has gotten very slow for me since I updated. I am on the crappy new OS version. Yeah, I don't know if it's the latest patch version, but yeah, it's the one with the shitty glass effects. Yes, I hate it. Honestly, I don't know why how Apple could do something like this. Disgraceful. But anyway, so here's so oh, I know what it is. It's the last thing that I forgot to do. So here's what we need to do. When we are done reading a one of these guys, we need to clean them up, and we clean them up by setting sequence to 0. So in the video thread, once we're done with this, we do d.data dot seek. Oh shit, we don't have that. We don't have meta. We only have data. We only have data, but this is fine because next packet commit can do it. Oh, commit read. Okay. Meta at. Oh, but this is the new read index. Um. Okay, no, we don't do it like this. We do it like this. And we set sequence to 0. Okay. And that should that should allow recycling to happen in the jitter buffer. And there we go. Oh, but we pooped ourselves. So we pooped ourselves again. So first of all, it was still jittery and all kinds of fucky, despite the jitter buffer. That's not good. It lasted for longer, but then it stopped working again. Why? What is happening? Well, where's my video stream thread? So we have all this stuff in here. Yeah, there's still something kind of going wrong here, though. I think the video thread is like it's not running. Why is it? Why is this guy running this often and the other guy not running at all? I mean, it makes sense that this guy runs faster because this guy runs every time we receive a chunk, which is pretty often, and it is fine. But we need to see this guy run. So here's what I'm gonna do. Let's pay the indentation level price, and let's put a print in here every time we run. Running video thread. Yeah, let's see this happen. Because this guy's filling up so much. That being said, yeah, I think we're just weirdly slow. Too slow. I think my sleep here might be wrong. Hmm. Okay, running video thread. Running video thread, running video thread, running video thread. So how could it be that this guy is full and this guy doesn't know what to do? Okay. So some minor kinks that still need to be fixed, but it's 9 p.m. So here's what I'm gonna do. I'm gonna stop the stream here because I have to at some point. Maybe I'll work on these on my own tonight. Maybe not. Maybe I'll resume tomorrow. In any case, it's a matter of fixing these last few timing issues, and we should have something that puts frames on the screen at the right intervals. Now, this doesn't fully explain to me though why the video is not really smooth and instead it's like weirdly jittery. But who knows? Well, I don't know. We'll see. Anyway, thank you all, and we'll see you next time. Let's see. Is anybody doing Zig? Nope. And then I'm gonna be lazy. So thank you all, and I'll see you next time.